Hey everybody, welcome back to the bench. So I got an interesting little project going on. And a couple months ago, a friend of mine asked me if I could make him some 45 ACP shot shells. Now, they're not that uncommon. You can get them from CCI, new production, aluminum cased. And they were common actually in World War II as a survival item to use in the 1911 pistol. And I think they were marked as M12 and M15 cartridges. And it was just a 45 ACP case, not too unlike one of these here. But instead of the case ending right here, it had something of a shoulder, and then it came up a little bit further to sort of simulate, if you will, like a round-nosed bullet. And then it had an open end. And inside was a powder charge and a wad, and some shot, and another wad or cup crimped over it with like a roll crimp. Halloween. Too much candy. Anyway, so I started doing some research, and there's tons of videos out there on the internet, especially on YouTube, about how to make 45 ACP shot shells with 40 Smith & Wesson dies and 41 Magnum dies and this die and that die. And, you finagle this, finagle that. And then there's a few guys I found on forums that actually, are machinists by trade, or at least by dedicated hobby. And, they would take a piece of, all thread stock or something, like 7/8 by 14, so they could put it in a reloading press and drill it out and ream it and do whatever it is they had to do. Well, I decided to see if I could do it more simply with things that you could pick up at pretty much any home improvement store. Home Depot, Lowe's, Osh, whatever. And so far, I'm having success. Now, we're not going to go all the way through to loading and firing because I haven't built any of these rounds yet. But what I have figured out is the die portion for shaping the rounds and a couple little handy jigs for marking the donor brass. The donor brass is 308 Winchester. And so marking that so we know the proper place to cut it, and then we know the proper place or the proper distance to resize it in the die. So we'll start with the die. Here she is. And she is nothing fancy. This is a 1/2 inch male by 3/8 inch female bushing. It's made of brass. It probably came out of Guangzhou province in China. I have no idea. You can pick these up pretty much anywhere. They use for plumbing, so the plumbing section at your local home destruction store is the place to look. Now, obviously a 3/8 inch hole, which is 0.375 inches, isn't going to neck down my 45 brass enough. I need the 45 brass necked down to about 430, maybe 440, 445. Pretty much anything under 450, 451 is going to work okay. But a little extra slop isn't going to hurt because the part that's necked down is going to go into the rifling of the barrel. The round is going to headspace otherwise more or less the same as a 45 ACP round will. So, but you can pick these up for about $3, $4 from McMaster-Carr plus whatever they're going to tag you for freight. But you can usually find them in the plumbing section where they have stuff like refrigeration fittings and just other. I don't even know what the section exists for. So you want that, and then you want this. This right here is a 27/64 high-speed steel twist bit, just plain old drill bit. Nothing special about that. Again, this is something you can pick up at about any home improvement store. Now, if you go looking down the regular drill bit aisle, you're probably not going to find a 27/64. You'll find 1/2 inch, you'll find 7/16, and you're going to start scratching your head and wondering what the hell I'm talking about. So, what you want to do is you want to find their tap sets. This is a 1/2 inch tap. Actually, it's a 1/2 inch by 13 NC, so it's coarse. And to tap a 1/2 inch hole and put threads in it, you need to drill an undersized hole, and it has to be 27/64. And this is exactly what I needed and what I wanted. So I've got a tap that I'll probably never use, at least not anytime soon, but hey, I've got it. Actually, I take that back. You know what? I will use it. I have another project in mind that's going to go along with this, so that'll be in a future video. So you drill this out, And I did it in a drill press. Didn't use a lathe. Didn't use a mill or an end mill, anything fancy. Take your time. Brass up your bit first. Just brass it off, and then at a relatively low speed, just get it going nice and easy. You want to make a nice straight hole. Use the existing hole to pilot yourself in, and drill that sucker out. Wee wee wee. Sorry. Now once you're done drilling it, it's still going to be undersized. So some 220 grit sandpaper on like a 3/8 inch bolt. Just give it a couple of wraps around, then get in there nice and snug, and just give it consistent turns. Just keep turning it, and you'll get yourself pretty close to your final dimension. From the 220, I switched to some 400 or 400, and then some 600 just to kind of smooth it out. And you can see the finish on it isn't that great, but it's okay. It'll do for our purposes. I'm just going to get a little more light over here on this thing. Nah, not really. Anyway, it's not a mirror finish, but it'll do. Now the trick here is that you're trying to resize a piece of brass with another piece of brass. And that generally is not going to work too well because the brass wants to stick to itself. So having this as smooth as you can get it on the inside, good thing. When you go to do the resizing, lots of lube. You don't really have to worry about denting any shoulders. And I like to use Camp's mink oil. It's sold as like a treatment or preservative for leather, boots, shoes, whatever, anything that's pretty much leather can take it, except patent leather. So I use that, and I brush some on the brass before I size it, and I brush a good dab in here. This is one of those things where it's not a dab will do you, but a glob is going to do you a lot better. So that's the resizing die. And let's see, where's my caliper? So my final internal dimension was on that about 441. Focus. So that's about what you're aiming for. Okay? And a little bit bigger is fine. A little bit smaller is fine. I wouldn't go more than, say, 5 thou bigger. No, I'd go like maybe a thou or two bigger. Maybe even try to get it down to like 440. So maybe, 4 thou, 5 thou smaller. So that's that. Now, the brass, when we cut it, and there's multiple ways to cut it, you want it to be about 1.26 inches long, overall length for a 45 ACP round. And I cut it right at the maximum, because if I make a boo-boo, it gives me some wiggle room, some cheat room to file, trim, ream, chamfer, whatever I need to adjust. You don't have to have it at 1.26 inches. 45, I think the minimum overall length for 45 ACP is like 1.18 or something like that. I forget off the top of my head. I'd have to go grab the paper. But I just go for the max length, and then that way I can always take material off if I need to. And so what I did here, you can see this little doohickey. I just drilled, where is it? That right there, that's the mistake hole. This is the good hole. Mistake hole, good hole. It's kind of like a night after too many beers and you wake up in the morning with coyote arm, but that's another story. Besides, I think there's little kids around still. So, you drill this out with a, I'm trying to remember what size bit I used. I might actually use no, I didn't use that one. I forget what size I used. I probably used a true 1/2 inch bit on that. And I drilled it down to 1.26 inches. And so you drop that in. And then this little dealie, just a finishing nail, nothing special. I took a small file, and sharpened up the tip of the nail a little bit. So you drop a piece of brass in there, and you just, and a couple of staples to hold the nail down. And then you just slide the nail over to the brass, like so, and applying a little bit of pressure to the nail, you just spin your brass. Right, making sure the brass stays bottomed out in the hole. Right, and that's all you got to do. Just give it a few turns. That's not going to hurt the brass anyway. That's going to be the top of our finished case anyway. So you can see now you've got a nice little score mark. Okay. So you've got a nice target to work with. Now I've got a totally hokey redneck. You know what? That's actually insulting to rednecks. This doesn't even rise to the level of good redneck engineering, but cutting rig. It's a set of vice grips, Irwins, good ones, before they move their production to China, bastards. Piece of rubber gasket material, I think it's like, 1/8 inch, something like that. And all I do, I just wrap it around the end of the case, like so. And then just gently clamp it in the vice grips. Yeah, I need more than that. Come on, baby. Use the whole hand. I need the whole hand to grip, sweetie, not just the first 2 fingers. Alright, so you got that clamped in there. And then just a plain old rigid tubing cutter. You can actually get these at Home Depot. It's probably one of the higher quality tools they have. You can get cheaper ones. This probably cost me about 30 bucks or something when I bought it. I like it for 2 reasons. One, rigid, it's heavy duty. My dad, is a plumber. Most of his cutting tools are rigid for pipe, and they last forever. He's got tools that he bought, 40, 45 years ago, and he still uses them. They're still in great condition. They give you a reamer right here. It pops out. I don't know what this little square hole is for. It's got to be for something. I'll have to ask him one of these days. I never found an explanation for it. And they give you an extra cutting wheel here stored in the handle. Haven't needed to use it yet. Most of the time you're cutting brass and copper with these things. If you need the second one, it's going to be your grandkids that need it when they inherit the thing. If you're cutting galvanized pipe, then you probably go through one pretty regularly. So you just line up the cutting wheel with the score mark that you made. And this is always kind of dicey. And what I've actually been doing is putting the vice grips in a vise to hold them steady, but I'll just do this one freehand. So get that one. No, wrong hole. That's what she said. Of course, she didn't realize until it was too late. And right about, Alright, so we're lined up. We're actually maybe just a thou or so to the high side, which again is fine. You can't add material, but you can always take it off if you need to. And just tighten it down just ever so gently. You don't want to crank down on it or you'll distort the brass, and just start your spin. And as you go around a couple of times, you just give the handle a slight turn. Just a slight turn, just to keep that tension of the cutting wheel and the guide wheels more or less consistent. And you just go. Alright, and you'll hear it start to crack and snap. And that's it. There is your cut piece of brass. Okay? Now, the next, let's see, how are we going to do this? Alright. So the next thing we're going to do is a step that I just kind of figured out as I was having problems resizing these. What would happen is, despite marking them as in terms of how far I wanted this to go into here, and which it won't fit yet, obviously, it just gets started, I had to apply more force than I wanted to, and then the press, which is not a fine-tuned instrument, and I have no stop mechanism for this yet, go too far, and I'd end up with, basically effectively the rim, if you will, the rim equivalent of this, way, way too short. So when I drop it like in a Wilson headspace gauge, or a Wilson gauge, case gauge, it was just sitting way below flush. And you might get away with using those, but it's like, why bother? So you take this, and in my case I grabbed, here they are, needle nose pliers, hang on to that little sucker, and get your happy dappy propane torch, sparker, and we anneal. Now, most of the time they say you should anneal until it's red hot, cherry hot. I usually don't bother with that. The idea is to relieve the internal stresses and to realign the crystal structure of the metal so that it becomes more ductile. It means it basically will bend and twist and move more easily, and less rigid so that it's less prone to cracking. Yes, we've got something, there must be some powder residue or something in there burning off maybe, or something, I don't know, or carbon. But anyway, so we'll just cook it up, and you can see the color on the business end here changing. And it'll start to get that kind of pretty rainbowy color to it. Kind of get coppery, blue. And that's really all you need. And the nice thing about non-ferrous metals is when you're done annealing them, you can water quench them immediately. You don't have to let them sit around. and cool to room temperature like you do with steel. So that's more than enough. Fill the torch there. And I got, I forgot to grab some water, but I think this is water. Hopefully it's not gasoline. No, it's water. Stinky water. And then in it goes. Don't break glass. Thermal shock bad. Yeah, it's kind of get toasty and roasty. That should probably be good enough. Hopefully I can touch it without melting this glove to my hand, otherwise I'm going to have to get my mom on speed dial and tell her to come fix me. Fine. Okay, so the next little rig that I worked up that I'm not really satisfied with, but it does in a pinch. So now we got to figure out where our resizing dimension is going to be, right? Right, okay. So again, 45 ACP case, and I cut that to the length that I wanted. It's about 895. Then I took another finishing nail. Well, before that, I cut, again, with the handy triangle file. Very versatile tool, by the way. Everyone should have at least a couple of them in their tool set. A couple of grooves across the diameter of the casing. Then I rested the nail in there. And I wanted to cut roughly halfway. This nail is like 0.072, so I cut down about 0.036. And what that means is that this point will be roughly just below the mouth of the case. And that's going to get me to the length that I want. That's going to get me to where I want the shoulder to form on this piece of 308 brass that I've cut. Now, this is really hokey, but anyway, you just kind of line it up there against it. And, oh, by the way, this is hot glued down. I'll eventually pop this off and drill it and tap it and screw it down. And this nail just held on with hot snot. You know, the stuff's handy in a pinch though when you're just trying to get something done to see if it'll work. Prototyping. We'll call it prototyping. And I sharpened that nail again with the file as well. So you just lay it up there and you just give it a twist. All right? Doesn't have to be super hard against it because again you're running now a relatively soft piece of brass against a relatively hard piece of steel. Right. And I like to give it a few twists. I just want to make sure I have a good reference mark to work with. Because once you're at the press, if you lose that mark and you can't figure out where you got to go up, stop, remeasure everything, and go from there. All right. So now you can see that there's a pretty good scribe mark, right? I need my pointer thingy. Let's see, right? There. There's my scribe mark, and it's even all the way across the case. And that's it. So we've got an annealed piece of brass. It's been marked for resizing. We've got our die. So now we're going to go and head over to the press and make a piece of 45 ACP shotshell brass.